Hi folks, here is a tutorial on how to put the Hall sensor for the C chip on wires. As you might know, the Hall sensor for the C chip is connected via a ribbon or a flexible printed circuit. The function of the ribbon is to give you some flexibility for installing the Hall sensor onto a chassis in the most ideal place that you can find. Now, here is the picture of the actual ribbon. So as you can see, there is the old sensor that is connected to the part that goes into the chip, onto the socket of the chip via some printed tracks. So the old sensor is actually, these small items up here. The ribbon is flexible enough as long as you fold onto itself. However, this is almost never the case when you need to install it on an actual chassis. So here's an example of where you need to introduce a 90-degree bend. So this bend, what cause is kind of stressing the tracks are printed on the ribbon, and over time can cause the track to break. And once you have a breakage on the tracks, the connection between the old sensor and the chip becomes unreliable, and the chip will stop counting laps or become erratic. So it must be said that this is older version of the ribbon. So Slotty has a newer version with less holes in it, like you can see here, which should make it a bit more reliable or durable, but still is not having the ideal. What I prefer actually is the approach that we have for the B chip. So this is a version of the B chip, Oxygen B chip, where the old sensor is actually connected to the chip via wires. Wires are much more flexible than the ribbon. In terms of installation, you can make whatever kind of bends you want, and they can take a bit more abuse, let's say. The point of this exercise is to get rid of most of the ribbon and just utilize the part that goes into the chip. So where you have these six uh, soldering pads, let's say, and the other end where the whole sensor is. So as you can see, there are six pads connected to six tracks, but the all sensor only has three pins. So we need to map these pads to the three pins into the whole sensor. So as you can see here, basically each of these two pads are connected to one input or output from the whole sensor. And so what Slotty has done is kind of mirrored these the actual information traveling on the pad. So as you can see, we have 1, 2, 3, and then 3, 2, 1, where 1, 2, and 3 are mapped to specific pins onto the whole sensor. Here also the R, Y, and B represent the colors of the wires that I'm gonna use and how they're gonna be soldered onto the pin into the whole sensor. Moving down to the other part of the ribbon, here we have the actual device, the sensors, and as you can see, I have numbered the pins that are on the whole sensor, and so there is a specific mapping with those six soldering pads on the part that goes into the chip. And also I have color coded these pins so that I know which wire goes where. So in the ribbon, as you can see, there are three other, at the other end, there are three soldering pads that are connected to the tracks that go into the pins in the whole sensor. So, pretty straightforward here. So the left side one goes to pin 2, the center one goes to pin 1, and the right one goes to pin 3. If everything goes according to plan, this is what you will end up with. So there are the two parts of the ribbon connected through 3 wires. If you want to attempt this operation, say yourself, be aware that you will need a very fine tip for your soldering iron. Here, the one that I'm using just for reference next to the ribbon. Okay, so let's start with cutting the parts of the ribbon that we don't need. I might say that here I'm using a ribbon that I know does not work, so I'm just savaging parts here. So as I said, you're using the part that goes into the chip, and then the part that it's where basically the whole sensor is sitting. So, and here what I'm trying to do is preparing these bits for soldering. So the first step that I'm gonna do is gonna put some flux in order to help with the soldering. Will let the solder basically go easier on the pads or on the tracks that where I'm trying to attach the cables. So here, just spreading them around, spreading the flux around. And here I'm gonna do some pre-thinning of the tracks and the pads where I'm gonna solder the wires. So the soldering is not the best that I've ever done because I have the mobile phone that I'm using for recording these videos in front of my face, and it's not that easy, let's say. But you get the gist of what I'm trying to do. Sure that with that phone this will be much smoother as an operation. Actually, I'm pretty sure because I did without the phone. So this is the second attempt that I'm doing. So here, if you see, I'm trying to put solder on the track on this part of the chip of the ribbon that goes into the chip. And what you have to be careful here, you don't have to fill the full track because otherwise it will not fit in the socket in the chip. So I'm trying to try to basically put solder up to half of the, or a bit of less than half of the track. Yeah, I should have cleaned the tip when there's too much extra solder. But anyway, so here I will show you how I'm soldering then the wires to the track. Again, sorry about this is not the best soldering that I've ever done. Again, it's mainly due to the phone being in front of my face. So here you have to try to be careful that you don't have solder across the track, and this the end results. And then here the wires are gonna be how they look like when attached to the whole sensor bit, and this is the final product that you can see. These are some pictures of the whole sensor installed into a car and how it's connected to the C chip. As you can see, there is plenty of space for connecting or soldering the wires onto the bit that goes inside the socket. And here you can see how uh, the wires give you extra flexibility for installing the whole sensor. In this specific case, I'm using 32 AWG wires. Um, I think this is the thickest one that I would use because otherwise you will have problems soldering the wires into the pads the bit that goes into the socket. If you want to, you can also remove the tape or the ribbon from the whole sensor device and connect it directly to the wires as I've done over here. And since you're doing that, then why not using the whole sensors for the B chip? So what you can see here is a whole sensor device that has a similar spec to the one used in B chip that can be installed or soldered to any wires. So here you can see the whole sensor for the B2 chip connected to the wires and to the piece of ribbon that goes into the socket of a C chip. And on the right, I'm showing a diagram on how to correctly, the order in which the wires need to be soldered onto this device, remembering that the bill side needs to point down. This is a final shot of how then the sensor gets installed on a chassis. To wrap this up, here short video of the chassis with the C chip and the B2 Hall sensor device connected to it. So I'm in the video, I am kind of recording while with one end and I'm driving with the control on the other hand. So yeah, you can see the car passing over the start finishing line, counting laps. I recorded on chrono. Second lap. Third lap. Fourth lap. So now I'm gonna switch to show you the car going around. You should hear also the beep confirming that the lap has been counted. So again, not the easiest thing to film and drive at the same time. Also, as you can see, there are no false laps or short laps. So here you have it. With this approach, you can get rid of the ribbon and use a wide-based approach. You can use an existing ribbon if you have it, or a ribbon, for instance, that is not working anymore. Or you can go to the other extreme where you can have the whole sensor device used in the B2 chip and install it or use it with a C chip. So I hope you like it and find this useful. If you have any question, leave them in the comments and I will endeavor to answer. Thank you for watching.